Okay, in this section we're going to take a little intro look at some aspects of trigonometry, and we're going to start off with how mathematicians measure angles on a coordinate system, so on the Cartesian plane. And so let's just sketch out what I mean by a Cartesian plane. We've got a y-axis, and we have an x-axis, and this part of the x-axis where the x values would be positive is actually called the positive x-axis, and that's going to be a very important part of the system of how we're going to measure these angles. So there's your positive x-axis, and then we imagine some sort of an arm that stretches out, and it really can stretch out to infinity, or it can stretch out to a point, and that arm can be swiveled, so it can be moved over to here, or it can be moved down to here, it can be moved out to this way. And so you get this essentially a radius, and you would create a circle of points around the origin. But let's just take a look at what happens in that first quadrant. And again, the quadrants start with 1, and then 2, and then 3, and then 4. And what we are doing with this line called the terminal side, or the terminal arm, is we are rotating it. And the distance that we rotate it is an angle. And for us, we're going to measure that angle using a variable. We don't want to use x, which we would normally use because that's already been used for the x direction. So we'll use a new variable called theta, and that'll be how far do we move this terminal arm starting from 0 degrees being the positive x-axis. So if we move that terminal arm all the way up, straight up and down, it would be at 90 degrees. And then we could move it all the way around to 180 and back to 270. We could keep flipping it around to 360. And this idea of spinning through 360 and ending up where we started has the name called a coterminal angle. So 0 degrees, 360 degrees. If I did it again, it would be add another 360, which would give us 720 degrees. These are, and you could keep doing that forever, and in fact you could subtract. You could go to negative 360 degrees, and on here negative is moving the terminal arm in the other direction. So a skier spinning one way in the air versus spinning the other way in the air would be the idea of coterminal angles. And so you could subtract 360 or subtract 360 again, etc., etc. And all of these angles are coterminal. And co means with or in the same place, and terminal means ends. So this terminal arms are ending in the exact same location. So if you, first of all, if you measure these angles in the direction that my blue arrow is showing here, which is counterclockwise, you get positive angles. And if you switch this around and instead go the other direction, which would be clockwise, you would get negative angles. So if you said, well, what's negative 45 degrees looks like? Well, it would be the other direction and 45 degrees. That's what negative 45 degrees would look like. Whereas 200 degrees would look like 180 plus another 20. That would be 200 degrees. And I motion it with this arrow to show which way. So 200 degrees positive would be the same as some negative angle. In fact, you could figure that out. 200 is 180 plus 20, so this is 180 minus 20, so it's 160 degrees negative. So those two are coterminal to each other, and you can also see that because if you take 200 degrees and you subtract away your 360, which is what I was getting to up here, you end up with negative 160, which is coterminal. So 200 and negative 160 are coterminal to each other. So lots of vocab to start off with. We've got these terminal arms spinning around, we've got these x-axis and y-axis quadrants, and counterclockwise and clockwise, positive and negative angles, and now we have this idea of coterminal angles, which are angles that end up in the exact same place. And you can generalize. If you have, say, 45 degrees and you want to find coterminal to it, well, we saw that you can add 360 degrees, and you could add it once or twice or 3 times, and you could also subtract it. And mathematicians just say, well, add it n times. So maybe n is 5 or 10 or 20, or maybe n is negative. Maybe it's -2 or -6. And the way that we can make sure that n is a whole number, because you don't want to add 2.5 spins or 1/4 of a spin, is you just say make n an integer. So if you add 360 degrees any number of times, or subtract it any number of times, you will end up with coterminal angles to, say, 45 degrees. So let's just move on and say that we have an angle of, say, -60 degrees, and it would look with a coterminal line something like this. Or we had an angle of, say, 540, that's 540, so 550 degrees, which would look something like this. There's 550 degrees, and there's my little arrows. Or let's say you had 135 degrees, which would look something like this. Now, each of these terminal arms is in a different quadrant. I've got one in quadrant 4, then one in quadrant 3, one in quadrant 2. You could imagine one that ends in quadrant 1. And my question for you is, what's the smallest angle between the terminal arm and the closest x-axis? Okay, well, that's quite a statement. So it's got to be small and positive, and it has to be between the terminal arm and the closest x-axis. So let me just draw in red. Here's the terminal arms, and there they are. And let's see if we can figure out the closest x-axis. That would be this one, this one, this one. And now I want the smallest positive angle that's in between. So there's the smallest angle that's in between. Here's the smallest angle in between. And here's the smallest angle in between. And let's see if we can calculate how big that smallest positive angle is. So if this is -60, if that's what this picture is showing, this angle right here is +60. If this is 540 degrees, well, we figured out that it was 540 plus another 10, so this tiny little angle in here is just 10 degrees. And 180 and 135, the difference between here and here is 45 degrees, and so there's your smallest positive angle between that terminal arm and the closest x-axis. And this idea of finding the smallest positive angle between that terminal arm and the closest x-axis is called a reference angle. So anytime you are asked to find this small positive angle between the terminal arm and the closest x-axis, that is this equivalent to being asked to find the reference angle. So anytime you're asked to find the reference angle, just look for these little blue angles. Make sure you're going to the closest x-axis and that they're always acute and positive. Okay, one final thing is, I mentioned that the system that we're using, the terminal arm could just be a point. So if, for instance, the terminal arm goes through the point 4, 3, there's your terminal arm, and it just goes to some point, and we think about that as being that point could rotate around being a circle, then this line here, this distance, is really your radius. I'll just call that r, so this is really your r. And we could actually figure out, if we know the actual point that it goes through, we could figure that out, because this distance here we know is 4, and this distance here we know is 3, and we know these meet at 90 degrees, so really what we're solving is a right-angled triangle with a base of 4 and a height of 3, and we're trying to find the hypotenuse. So we can use a squared plus b squared equals c squared, and solve to get 25 is c squared, or c is 5, and this radius is 5. So we can actually start to extend, given some more information, like what a point is that is on the terminal arm, we can start to extend these ideas to allow us to calculate the x value, the y value, and this r value, this radius value for these triangles that we can start to see given any point that's on a terminal arm. Okay, we'll explore this a lot more in class. See you then.